let's consider this inequality y is greater than 4x minus 1. Remember, to solve an inequality that has two variables, you have to show all points whose coordinates make this inequality true. This is how you do it. First of all, we need to change this inequality into an equation. So instead of greater than, I'm just going to write equal to, which this should look familiar to you because all this is the equation of the line in y equals mx plus b format that we can graph. Graphing this requires you to place -1 on your y-axis first. After that, we will use our slope, which is this 4 over 1. So I'm going to travel 4 units up from my -1, 1, 2, 3, 4, and 1 unit to the right. I ended up right here, and I'm going to connect them, and here is my line. Once you create the line, you have two options. You can keep it solid, or you can make it dashed. The line will be kept solid if the inequality symbol in your original problem is either greater than or equal to or less than or equal to. The line will be made dashed if the original symbol is greater than or less than if it's missing the equal to. Clearly ours does not have an equal to, so I need to go ahead and dash my line. Once you have your line and you decided if it needs to be solid or dashed, your next and final step will be to show what side of this line, the left or the right, has the points that make your inequality true. Now, of course, the yellow side and the blue side, they all have multiple points and you cannot possibly check every single one. But the good news is once you check one of the points on one of the sides, you will know that the rest of them will work the exact same way. So my suggestion is we pick a point anywhere on the picture. Just make sure that it's not on the line. For example, I can pick this point which has coordinates -1, 1, or I can potentially pick this point here which has coordinates 3, 1, or maybe I can pick a point that is right here which has coordinates 1, -3, etc. It doesn't matter which point you pick as long as it's not on the line. I'm going to use my blue point. I'll erase the rest of them. And what we will check is if this point with the x coordinate of 3 and the y coordinate of 1 satisfies this inequality. So I will be making my y a 1 and my x a 3. Now notice I am not checking in the equation here. I am checking in the original problem. Simplifying this gives me 1 is greater than 12 minus 1, or 1 is greater than 11. Is this true? Is 1 actually greater than 11? No, it's false. 1 is smaller than 11, which means the point that I picked along with all of the other points on that side of the line is a false point, meaning the other side is actually the true side. And you can pick a point and check, but by default, if the right side was false, you will go ahead and color the left side. Here is another example. You have an inequality 3x minus 2y is greater than or equal to -8. Remember, the first step is to make it into an equation, which creates the standard form of the line, ax plus by equals c, and we have a couple of options to graph it. We can find the intercepts, or we can change this into y equals mx plus b, which is the option I'm choosing. So to make this to look like this, I will first take the 3x that is currently positive on the left side and move it to the right by making it negative. this is what I have now. Negative 2y equals negative 3x. I'm going to go ahead and write that first, and then negative 8 comes after. Now I need to remove the 2, which is multiplying my y, so I will be dividing by negative 2. Notice that next to the x, I have a fraction, 3 over 2, because 3 is not divisible by 2, but I did make it a positive fraction. So let's graph this. My first point on the picture will be a positive 4, which is my y-intercept right here. And after this, I need to use my slope to travel 3 units up and 2 units to the right. Now, instead of going 3 units up and 2 to the right, which puts me out of the boundaries of my picture, I will go 3 units down and 2 units to the left, which will result in the exact same line, but I will stay within the boundaries. So I'm going to connect them, and here is your line. The next step is deciding if I'm making this line dashed or if I'm keeping it solid. I'm keeping this line solid because the inequality symbol was greater than or equal to. Now I will be checking if the coloring will be done on this side or if it will be done on this side here. Do not color both sides. You have to pick either yellow or the blue. So for that, I will be picking a point. I'm going to go ahead and pick this point here, which will be checking the blue side. This point has coordinates 0, 0. So your x is 0 and your y is 0. I will be replacing x with 0 in my original problem, right here, and y with 0 in my original problem. So that becomes 3 times 0 minus 2 times 0 is greater than or equal to negative 8. So 0 minus 0 is greater than or equal to negative 8, which is 0 is greater than or equal to negative 8. Is this true? Is 0 actually bigger than a negative number? Yes, this is true, which means the point that we picked, along with the rest of the points on that side, will create a true inequality. So that is the side I will be shading. Here's question number 3, and this one is a system, which means you have to do the same work we just did twice on the same picture. So your first line here, once you make it into a line, is x equals negative 2. As a reminder, this is a vertical line that passes through negative 2 on x-axis, and this line will be solid because the symbol is greater than or equal to. To check which side of this line I will be shading, I will pick a point somewhere that is not on the line. I think I like 0, 0. So that is checking the right side of the line for me. I will be replacing x with 0 in my inequality here. And I technically have to replace y with 0, but my inequality does not have a y. So I will simply be replacing x only. So that gives me 0 for the x is greater than or equal to negative 2. This is actually true because 0 is bigger than a negative number. So I will go ahead and shade the side of the line where this point was located. So the second inequality is y is greater than 4. I will make it into an equation. So y equals 4. Now remember, this is a horizontal line that passes through 4 on y-axis. This line will be dashed. So this line has two sides, above it and below it. I will go ahead and pick the exact same point to check the below portion. So point 0, 0 checks this part for me, and we see if this red part is true or if I will be shading here above the line, which side is true. But I'm checking the one below because that's the point I picked. So in my inequality, I'm replacing y with 0. So is 0 actually bigger than 4? It's not, it's false. So wherever that point was, which for us was below the dashed line, is a false side. So I'm going to go ahead and shade above the line. Here's the final question. This one is asking you to create an inequality that will represent the picture. We will start by creating the equation for the graphed line, this line right here. And once we have the equation, we will then change it into the inequality. So this can be done multiple ways. The easiest to me appears to be to write the y equals mx plus b, simply because you already have b, which is this 2, and you already have the slope. It's a positive slope of rise 2 over run 3. So this equation will be y equals 2/3 x plus 2. Again, 2/3 is your rise over run. It's positive because the line is rising from left to right. And this plus 2 is your b, the y-intercept. Once you have your equation, you will then look at the line itself to determine what type of symbol for the inequality will fit into this picture. So remember, you have 4 symbols that you can use in place of this equal to sign. It can be greater than, it can be less than, it can be greater than or equal to, or less than or equal to. Now the last 2 I know won't work because my line is dashed, and those will need to be used for a solid line. So it's either greater than or it's less than. What I'm going to do is I'm going to first write the same problem but with this greater than symbol. So y is greater than 2/3 x plus 2. I also know that the points that are in the yellow part of the picture are all true points, and they will satisfy the inequality. So what I will do is I will pick a point that is on the yellow side. Again, I really like this 0, 0, but you can pick whichever point. This is your x and this is your y. And I will replace the x and the y with 0 inside of the inequality and see if the point works for my inequality. So 0 is greater than 2/3 times 0 plus 2. 0 is greater than 0 plus 2, or 0 is greater than 2. Is this true? No, 0 is not greater than 2. This is false, which means this symbol didn't work either. So the only one that's left for us is this symbol right here. So my answer will be y is less than 2/3 x plus 2. Now you may see this question as a multiple choice question, and instead of being in y equals mx plus b form, your inequality will be in standard form. Keep in mind that you can easily convert this slope-intercept form into standard form by first moving 2/3 x to the left, and then removing the fraction by multiplying all terms by 3. And here you have one that looks like standard form.